16. What's 16 times 4? Somebody do it on the whiteboard. Let me know. Raise it up when you got it. Raise the whiteboard up. 64. Very good. 64. Okay. So you see we looked at our exponent, which is this number up here. And then we looked at our base number, which is this number down here. And we just wrote it 4 times with our base number, or 3 times. We wrote our base number 3 times. And we just put multiplication signs in between them. And that's how we solved it. Okay? So if that's exponential notation, then when we write a normal number, just like 250, if I write this, just 250, is that exponential notation?
No.
No? Does anyone know the name for that? Ronald? Standard notation. So this is standard. That's standard notation. So the normal way that we see numbers is standard notation. Okay? So if we have 25, what is that written in? Is that standard notation or is that exponential notation? That's standard notation. Now what if we put a 2 up here? Is that exponential notation or standard notation? Okay, Christian, how would we say that? How would we read that?
25 to the power of 2.
25 to the power of 2, very good. And how would we solve it? What would we write on the page to solve?
Right. 25 times 25.
25 times 25, very good. Okay, so when you ask somebody if you can borrow $25, you could also say what? If you want to say it in exponential notation. What would be $25? So what number times itself gives you 25? Nelson. 5 to the power of 2. Very good. So if you need to borrow $25, you can say, can I borrow 5 to the power of $2? Okay?
Mm-hmm.
Alright, so I'm going to give you an example. Let's do, everyone on our whiteboard, let's do 3 to the power of 3. And hold it up as fast as you can, as soon as you finish. Hold it up. Keep it up so I know you finish. Keep it up. Okay, very good. So everybody put 27. But I'm going to say that I noticed a few of you, I think you may have been rushing, you said the answer was 9. Okay? So you had, instead of that 27, you had this. 3 to the power of 3 equals 9. So why is that wrong? Yeah, it's not 3 times 3. Okay? Just because you see a 3 with a little 3 above it doesn't mean 3 times 3. What is it supposed to be, Katie? It's supposed to be this. 3 times 3 times 3, which is 27. Very good. Okay, so you need to, that's why we can't rush through these. They may seem easy to you, but even if they seem easy, take your time. And remember, it's not just 3 times 3, or if you have 3 to the power of 2, it's not just 3 times 2. It's 3 times 3, okay? And that's a big difference. If you do 3 to the power of 2 and you get 3 times 2, that's 6. And 3 to the power of 2 should actually be 3 times 3, which is 9. Okay? So we need to pay attention to that. Alright, let's what I really want you guys to do, why don't you pair up? We have 1, 2, 2. Why don't you 3 work together? Then we'll have Christian, you can work with Crystal. You two. Americo, why don't you move your chair over next to Fernando? No, just use Fernando Whitewood. Okay? And we have 2 here. And Lorraine, could you move here, please? And work with Ronald. Okay. Or actually, it'll be easier. Why don't you work across with Diana? And then Ronald and Jose can work with. Okay, so what we're going to do, we're going to give you just a few minutes. You're going to give each other exponential numbers to figure out, okay? So if I'm working with Taylor, then I'll tell Taylor, I'll write on her whiteboard, I'll say, okay, any number I want. So I could write 10 to the power of 2, okay? And she has to solve it, okay? And then after she solves that, she writes one for me. So maybe she'll write 3 to the power of 4, okay? And just do that back and forth for just a few minutes, okay? And monitor each other's progress, see what mistakes you're making, and if you see anyone making a mistake or if you're unclear about anything, just talk with each other about it. Collaborate and try to figure it out, okay? Yes? Don't use the calculators for right now. I guess I'll tell you what. If somebody gives you a really tough one, they give you like 10 to the power of 6 or something that you think is really difficult, then you can use it. Okay? So let's keep our exponents under 4, okay? Or under 5, Okay, let's keep them under 5. So we can do 10 to the 5th, but nothing over that, okay? Okay, so I'll just give you a few minutes for that. So you guys, it's okay if you talk together and collaborate. That's right, Katie. Nice.
Yep,
You can write it out. You don't have to do it in your head. If you need to write it out, that's fine. 15. Now, what do you think you did there? Do you think you multiplied? 5 times 5 times 5.
No.
Looks like he added to me. So you get 5 plus 5 plus 5, which would be 15. There you go.
Got it.
Yeah, you guys shouldn't need to use your calculators to solve the exponents. You shouldn't be writing, in your calculator 4 to the power of 3. I said you can use the calculator, but you really only need to use it for, if you have 4 to the power of 3, you're going to write out 4 3 times. So So just use your calculator that way. Write it out, and then do 4 on your calculator times 4 times 4. You don't need to use the power function yet.
Yes, I got 2,401. It's like 126. I was going this way. I was multiplying. Okay. And then you give me one.
Just 68,000. That's 11 to the 5th power. 10 to the 50th power? You can do it. 10 to the 50th power. You can do it, but it's going to take you a long time. You'll probably be in during recess.
Why did it say 1 times 10 to the power of 50?
See your whiteboard there? Thank you. Okay, everybody, I just want to point something out, okay? So a lot of you wanted to do 10 to the power of, 6 or 5 or whatever the number. We even had Diana over here said 10 to the power of 50. Okay, so one trick that you can do, you notice how she's trying to figure out 10 to the power of 6 by writing 10 6 times and multiplying it? Okay, so a trick is, instead of writing 10 6 times and multiplying it, you can just do this. 10 to the power of 6. You can simply write it like this. 1, then our exponent is 6, so we put 6 zeros after it. So 1 0, 2, 3, 4, 5, 6. Okay, so what is 10 to the power of 6? 1 million. Yeah. So that's a shortcut. So if you have 10 to the power of 50, Diana, now that you know our shortcut, what do you think 10 to the power of 50 would look like? It's going to be a lot, yeah. But how many zeros are we going to have after our 1? 50. Good. So we're going to have 50 zeros, and I don't even know how you say that number. But we'll have 1 with 50 zeros after it. So if we had 1 or 10 to the 1,000th power, what would that be? That would be 1 with how many zeros after it?
1,000.
Yeah, 1,000, not 10. It would be 1 with 1,000 zeros after it. Okay, so anytime you have 10 to the power of a number, it's just a 1 with that many zeros after it. So just to show you that that is always the case, let's do 10 to the power of 2. Now we know we would write that as 10 times 10, right? So what is 10 times 10?
100.
It's 100. Okay? So if we would have just used our simple rule of saying we look at the exponent, which is a 2, and we take a 1, and we just put 2 zeros after it, aren't these the same answers?
Yes.
Yeah, 100 and 100. So we can just do that, okay? But that's not the case with every number. That's just 10, okay? And then you can figure out how to do it with 100 and stuff, but it's very easy with 10 because you just add just that many zeros, okay? All right, so does everyone think they understand about exponents?
Yes.
Is anybody unclear about it? Raise your hand if you have any questions that came up during the partner share or during the lesson.